Today we will see how to evaluate the integral 1 over square root x squared minus 8x plus 15 dx. Please note that this is an extension of our discussion that we started at the beginning of this week, which was about integrating square root ax squared plus bx plus c dx. There's a complete separate video explaining how to evaluate this integral, and I'll have the link posted down below in the description for those who have not yet watched that video. The same methods can be used to evaluate the integrals of the form 1 over square root ax squared plus bx plus c dx as well. Now this is an example of that form where the square root term is in the denominator. Since all the methods were discussed with this integral in that video that I released on Monday this week, I'm not going to talk about all the methods in this video. Instead, I'm going to directly apply those methods and evaluate the integral given right here. Those who need help evaluating this integral right here, please go ahead and watch the video posted in the link down below. Alright, let's go ahead and start evaluating the integral 1 over square root x squared minus 8x plus 15 dx. As always, you can start this question by looking at the discriminant. You can show that the discriminant b squared minus 4ac is positive for this question, and also a, the coefficient of x squared, is equal to 1, which means a is also positive. In that case, we know that we are going to need some form of a secant theta substitution. But we know before using any substitutions, we have to first complete the square. So let's go ahead and do that. Integral 1 over square root. Inside the square root, I'm going to complete the square as x minus 4 squared. And we have a plus 15, and I need to subtract 4 squared, which is 16. All that's inside the square root, and we have a dx term. Now this is equal to integrate 1 over square root x minus 4 squared minus 1 dx. Alright, now we are all set to start the substitution. So in order to decide the substitution, we look at this term, which is x minus 4 everything squared. Therefore, we start the substitution as x minus 4 equals. And we will have a coefficient times secant theta. And that coefficient is the square root of the number right here. It is 1, and the square root of 1 is just 1. Therefore, the substitution should be equal to just 1 times secant theta. And then I need to differentiate both sides of that substitution. Then we get dx being equal to the derivative of secant theta is secant theta tangent theta times d theta. Now we can go ahead and use them in this integral. It's now equal to integrate 1 over square root x minus 4 is equal to secant theta. X minus 4 squared should be therefore equal to secant squared theta. And then we have a minus 1. Complete the square root, and then we have dx. dx is equal to secant theta times tangent theta times d theta. Alright, now we can do some simplifications. We know from the second of the 3 Pythagorean identities from trig that tangent squared theta plus 1 is equal to secant squared theta. The terms of that can be rearranged to see that secant squared theta minus 1, which is the term inside the square root, is equal to tangent squared theta. Since this term is inside the square root, when you take the square root from tangent squared theta, it becomes a first order tangent theta. That can be therefore simplified with the first order tangent theta on the numerator. Now the integral has become equal to integrate secant theta d theta. Integration of secant theta is equal to natural logarithm absolute signs secant theta plus tangent theta. Since this is an indefinite integral, I will also have a constant added, which is the arbitrary constant. Alright, now the answer should be kept in terms of the original variable given. The original variable was x. We have to look at the substitution again. The substitution that we used was x minus 4 equals secant theta. Now from that we can subject theta. We have x minus 4 being equal to secant theta. Well, of course, I need secant theta right here. Therefore, this is a part of the answer that I need. In addition to the secant theta term, I will also need tangent theta. In order to find tangent theta, I will once again use the second of the three Pythagorean identities, which is tangent squared theta plus 1 being equal to secant squared theta. From that, I can subject tangent theta as secant squared theta, which is x minus 4 everything squared minus 1, all of that square root. I did the simplifications a little bit fast, but I hope you are now familiar with these things, because this is the third example after publishing that initial video. Even the initial video also had 4 more examples. So this is technically the 7th example that we are working on from this kind. All right, now tangent theta should be equal to square root x squared minus 8x plus 16 minus 1 is plus 15. All that's inside the square root. All right, we are almost done. We can now write down the final answer. This is equal to natural logarithm, absolute signs, secant theta is equal to x minus 4 plus tangent theta. We found tangent theta right here. Tangent theta is equal to square root x squared minus 8x plus 15. Close absolute signs, and we have a plus k. Well, this is a final answer. However, if you would like to modify this answer a little bit more, we may do so. The modification can be done by identifying the k right here, a constant, as natural logarithm c for some value c. In that case, this final answer can be written this way: natural logarithm absolute value x minus 4 plus square root x squared minus 8x plus 15, close the absolute signs, that times c. That is a final answer. However, this simplification is actually not required. If you would like to do some further simplifications and keep the answer this way, that is also an option available. All right, now if you would like to try a homework question, I would like to give you one. So here's your homework question. Evaluate the integral 1 over square root x squared minus 12x plus 35 dx. You'll be able to see that even for this problem, delta, the discriminant, which is b squared minus 4ac, is going to be positive, and also the coefficient of x squared, a, is also positive. In that case, once again, you will need a secant theta substitution. There may be a coefficient other than 1 with the secant theta term. You have to figure it out yourself by completing the square inside the square root. All right, I hope you enjoyed this video. Thank you so much.